Okay, today we're talking about 1.6, least common multiple. Okay, let's look at our GVC or our I can statement. It says I can find the LCM or least common multiple using multiples, prime factorization, and Venn diagrams. Okay, LCM. Okay, what is the LCM? The LCM is the smallest multiple that two numbers have in common. The smallest multiple that two numbers have in common. Okay, in elementary school, you learn to find the LCM by skip counting. Okay, so let's do that to review what we might have learned in elementary school. Okay, in elementary school, you might have learned how to skip count to find them and list the multiples. For example, the multiples of 12 are, okay, if we skip count by 12s, we get 12, 24, 36, 48, 60, 72, and 84. If we skip count for 18, a little bit trickier, okay, we have 18, 36, 54, 72, and 90. Okay, remember you can always use your multiplication chart. These are just multiples of 12 and multiples of 18. Okay, so we're going to look on here and we're going to see what do we have in common. Well, I can see that we have 36s in common. What else do I have in common? I have 72 also in common. Okay. The smallest number they have in common is 36. So that is my least common multiple. Okay, the least is the smallest one that they have in common. In advanced math, the multiples get big fast. So prime factorization works best to find the LCM. So that is why we use prime factorization and a Venn diagram to help us find the LCM, because sometimes it gets hard to skip count numbers like 18 or maybe even bigger numbers than 18. Okay, so let's try one for 12 and 18 using what we know about prime factorization. Okay, we know that 12 can break up into factors of 2 and 6. Okay, 2 is prime, so I'm going to circle it. Okay, we know that 6 breaks up into factors of 2 and 3. Those are both prime. I'm going to circle them. Okay, 18. 18 can break up into factors of 2 and 9. Oh, sorry, 9 is not prime. I should not have circled that. Okay, 9 breaks up into factors of 3 and 3. Okay, so we should only have circled the 2, the 3, and the 3. Okay, so if we have a factor summary or the prime factorization of each, we have 2 times 2 times 3 and 2 times 3 times 3. Creating a Venn diagram, if a number is present in both summary boxes, it can go in the shared center space. Only write the number once. So for example, okay, we've done this before for greatest common factor. So I have the number 12 over here and 18 on this side. Okay, as I find them in common, I'm going to cross them out. Okay, so I have a 2 over here and a 2 over here. So it goes in the middle. I have a 2 here. Oh, there's none in common on the other side. I shouldn't have crossed it out, I'm sorry. But I have a 3 on this side and a 3 on this side, so there should be a 3 in the middle. Okay, and what is left is my 2 that I shouldn't have crossed out and my 3 that is left on this side. Okay, very good. So now I have the prime factors. These are the ones in common. The ones that are not in common are on the outside. Let's flip over our paper. The numbers who are left in the factor summary box get placed in their own circle. Okay, we've done that. Write down each number listed in the Venn diagram and multiply them. So we're going to look at each of the numbers. Okay, they've been written here for you. Okay, we have 2 times 2 times 3 times 3. Okay, so that's what they have written here. We have 2 times 2 times 3 times 3. Well, 2 times 2 is 4, 4 times 3 is 12, and 12 times 3 is 36. So the LCM, or least common multiple, is 36. Okay, Find the LCM of the numbers using lists of multiples. So first, okay, this first one, we're going to use lists of multiples instead of using factor pairs and a Venn diagram. Okay, together, let's try this one. Okay, we have 12 and 42. Okay, let's skip count to help us make a list of the multiples of 12 and 42. Well, we know that 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. 12 times 5 is 60. 12 times 6 is 72. And 12 times 7 is 84. Okay, now let's try 42. Well, we know that 42 times 1 is 42, and 42 times 2 is, 84. Okay, so we see that this one, the first or the least, the smallest number that we see in common on both is 84. So that is my least common multiple, or the smallest common multiple. Okay, I want you to pause and try to make a list of the multiples of 9 and 24 and find the least common multiple. You will pause, try that one, and you will check it with me when you're done. Okay, now let's try to find the LCM of the numbers using prime factorization. So this time, instead of making a list, we're going to first make a factor tree of both and then use a Venn diagram to help us to find the LCM, or the least common multiple, of 8 and 12. Okay, so let's make a factor tree for 8 and 12. Okay, we know that 8 breaks up into 2 and 4. 2 is prime. 4 can split into 2 and 2. Those are both prime. Okay, 12 can split into a 6 and a 2. 2 is prime. 6 can split up into 3 and 2. Those are both prime. Okay, now let's make a Venn diagram. Okay, my Venn diagram shows that, let's look on both sides. What is in common? Well, there's a 2 on both sides in common. What else is in common? There's another 2 on both sides in common. And what's left? Well, there's a 2 on the 8 side, and on the 12 side we have a 3 left. Okay, well, we know that if we write them out, all of my prime factors, as a multiplication problem, 2 times 2 times 2 times 3, we should find the LCM. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. So my LCM is 24. Okay, I would like you to pause and try. Okay, these two numbers are going to be a little bit bigger, so we definitely need to use prime factorization using a factor tree, okay, then a Venn diagram to help us to find the LCM. Pause and try, and then I want you to come and check this problem and this problem with me. When you're finished, then you can grab your assignment that is in your basket.